Hello everyone, welcome back to my channel. Today we are going to explore on how we are going to solve the regression issues using support vector machine algorithms, and by end of today's video you should be able to correlate the formulas, the hyperparameters, everything which we understood during our theoretical part and the mathematical intuitions which we understood, everything we can correlate by end of today's video. So stick to this video till end so that you will not miss those concepts, and let's start with the topic. So guys, here we are with our regressor issues, and I have taken employee salary data. So by end of this video we should be able to know how we can predict the salary of the employees based on their age, then education level, job title, then years of experience. All those factors or all those features are there, and we will see how those are correlated and all. So let's see. So the first part, what we are going to do, guys, we are importing our libraries. Then we are going ahead and loading our data. Then this is my head, and my head contains age, gender, education level, then job title, years of experience, salary. And my job title is containing many, actually 174 different types of job titles are there. Then my data.info is saying that I have 375 entries, and out of that I can see all are there as 373. That means 2 rows of each features are null. That means it's empty. Values are not there in that. And we have combining float and object types of data types present. And to verify how many values are there as null, so I can see that these are the values I have null, and we know is and is null are the methods which we can use. Then I have used my simple imputer to fill the data. That's the way we are doing, right? The feature engineering, correct? Or the data manipulation. So the data manipulation, like we are filling the data, and here I am using my simple imputer, and I have already shown you many examples by using simple imputers. Here we are we have a property called strategy, and that strategy can be mean, median, and most frequent. That's the same way we are doing for fill NA. That method we have fill NA. It's the similar way, but in fill NA we are going with the that conventional way. But here it's just using the pre-processing. Pre-processing means we are fitting and transforming the data, and this is the ideal way of doing it. However, you can do that way as well, and I have already shown you that example on how to do it. And so here for my numeric values, I have used strategy equal to mean. That means it is going to take mean value and it's going to fill those with mean values. So this is how we can do it. I am just directly assigning my column, and I am getting my imputer and fitting and transform, and I am using my the column here. The similarly here years of experience and salary. Then the next part we have the mode, because for for categorical values we usually take the mode. Mode means what, guys? The number of frequent items in that particular group or in the particular lot. So if what it will do, it will just go for look for gender. If male is more, then it is going to replace with male. If female is more, it is going to replace with female. However, if you will go ahead with most frequent, we are getting some errors. When I was trying, I was getting some errors on that you cannot perform this on 2D. So I have used Ravel. So my Ravel, what it is going to do, it's going to convert whatever the shape of the data to a 1D form, and most frequent is going to take that 1D form only. So just one line and everything is done. But however, in case of NL, you have to take mode, you have to calculate mode, you have to calculate mean, then you have to replace, or you have to place that values in fill NA, right? So those things are present. So if I'll run this, my job is done. And if I'll go ahead and see my head, I cannot see those values, however, but if I'll verify this, I can be able to see that my values are not present. Then, my null values are not there. All values are present right now. It's full. My data set is complete now. Then after that, I'm going ahead with pair plot, and in pair plot, I'm able to see all the histogram and the scatter plot among between different, like the univariate and bivariate relation of those variables. So again, I already said about it that pair plot can be seen on numerical data, right? And for categorical data, what we are doing, either we are going for count plot, right? We wanted to see the counts, or we can achieve that with using value counts. If you want to know how many counts of each categories are present, you can use value counts there. And you can see that like this is my gender. So in my gender, I can see that my male is more in the data set. Then in my education level, I can see that there are 3 different types of education level: bachelor's, master's and PhD. Then we have, so those are the 2 categorical values I am able to see. However, if you see this, why I have not seen the job title, because job title there are 100 and my bad, I think there are 100 and where is it? 174 different categories are present, which is not relevant for me to check. If I'll check, then I cannot see the visibility properly because the count is huge there, right? It's like a completely new row for each. There is no frequency of data. So next what we can do, we can see the box plot, and in my box plot I can see that the data looks good, and the box plot is again for numerical values, correct? So this is my head. I have I was trying something where I can show you both what is my plan, that I wanted to show you the nature of always we used to talk about how our regression works and all. I wanted to show you that from this example. So we have an in plot, IMPLOT. So in my in plot, I can show you the scatter plot along with the reg line for each feature. Suppose here I have taken my age and my salary. Okay. So here on my x-axis, age is there, and my y-axis, salary is there. And if you see the hue part, right? The hue part I am telling gender. That means my age and salary should be categorized or should be divided based on my gender. So here my male and female, 2 genders are there. And you can see my male is getting presented with the blue circle or the blue dots, and my females are getting presented with cross. So, and orange color and blue color, both are there. And if you see that, we are always thinking how these regressors and how these things are coming up. So if you just imagine that in this way, that it has created, it has created 2 different reg lines based on the feature, like for age and for age based on the hue, it has created 1 reg line. For salary, based on my hue, that my gender, it has created 1 more line. So you can see that how it behaves. So I always used to say that, okay, we have W1, in normal regressor, we have beta 1 x1, beta 2 x2, beta 3 x3. So this is how those behaviors are coming up, guys. This is how these behaviors are showing here. Similarly, if I'll go ahead with age and salary and the hue is education level, then you can see that I'm getting 3 different reg lines based on my hue, right? This is for my PhD, this is for my bachelor's, the blue one, and this is for my master's. Then similarly, if I'll go ahead with years of experience in salary and education level, I am getting the lines like this. So here we are clearly understanding that, okay, for each feature, it is understanding the pattern, and it is creating, or it is predicting the output in that direction. So we don't have a single reg line. We internally it is creating different reg lines and it is coming up to one final output, right? I mean, it's calculating in such a way. Then this is for years of experience in salary, and this is my hue, like this for male and this for female. So you can see that how it is creating different reg plots. So we have seen how it is creating a reg plot for normal two variables. But here we are able to see according to hue it is creating reg plots or the regression lines. Next, what is our step, guys? We have to convert the categorical values to the numerical values. So I'm going ahead and doing it, and after that I'm able to see that all my rows are getting converted. But is this enough? This is not enough, because we have to scale it down, because here the variations of numbers are huge. The salary is in a high end, then job title is in a high end, then gender and experience, these are in low end. So to compare that, the model will struggle. So for that we are going to scale it up. This is my heat map. So my heat map, you will see that age is having good correlation, education level is having good correlation, years of experience is having good correlation. Then gender is not having much, job title is having little bit but not much. But age, education level and years of experience have good correlation. Now we understood everything. We understood the correlation, we understood the regression lines. We know how it is reading the data through a pattern. Now we will go ahead and import our libraries of sklearn. So what my sklearn is doing, it is handling all the machine learning agenda, right? So for that we are going ahead and implementing my model selection. In my model selection I have train, test, split and gridsearchcv, because I am planning to show you the cross validation and hyperparameter at the same time. Then standard scalar pre-processing, I am going ahead and pre-processing the data. Then this is the important part, SVM, sklearn SVM module, SVR. So we have seen SVC, this is SVR. Then metrics, mean squared error and R2 score are the two things which I am planning to show you. Then we are going ahead with getting the dependent independent variable segregation. So I did that. Then after that I'm getting my x train, x test, y train, y test, right? So here what are the inputs it is asking? I need to get my independent variable, my dependent variable, my test size. You can put train size as well. So if I'll change it like this, train underscore size equal to 0.8, this will also work. Okay. Then a random state 42. It's up to you how you are planning to write it. So if I'll run this, I'm getting my x train, x test, y train, y test. Then after that I'm getting my scalar x, scalar x, scalar y, because we have two different features here, right? I mean combiningly two variables present. So I'm going ahead and getting it. Then after that I'm getting my x train and x test scaled, and I already told you why we are going here with fit and transform and transform. This is the trickiest question you will get during your interview. If they will ask you to write down the code, and if you'll write it, then they will ask you why you have done this. Then you should be able to in a position to answer. And I have already explained you that why we are doing fit and transform, because we wanted to train our data, train our model with trained data, not the test data. So only transform is going to convert the scale, or it is going to scale down all the features and it is going to keep it in a same level. But if we'll do fit and transform, it's going to train the data as well. So that's why we are going ahead with fit and transform for train and transform for test. Similarly, this is we are doing the same thing for my train scale. Then this is my shape. So if you see my x train scale shape is 300, y train is 300, x y test 75, right? And this is my SVR. I'm defining my SVR model. Then I'm going ahead, because we are doing the hyperparameter part. We are not directly going ahead with predicting the model. We wanted to perform. We wanted to know which hyperparameter is good, which cross validation is good. So we are trying, or we are going to explore those things. Now let's see. We are going to do gridsearchcv. So for that, what is the dictionary or the hyperparameter which like the variable which you are planning? We have param underscore grid, right? Inside that, these are the different hyperparameters. So you should be able to know, guys, whenever you're working on these models, that inside like the hyperparameters are specific to specific algo. So if you'll go ahead with decision tree, they're different. Then if you'll go ahead with elastic, it will be different. If you go ahead with any other models, it is going to be different. So you should know what exactly is the thing we are using in each algo. So we already understood that kernel function is the one. Okay, in kernel function we understood there are three different things. Sigmoid is the one which is getting used specifically in neural network. We will understand that. And RBF is the one which is the default one, I already told you. Then linear is for linear data. Poly means it's for non-linear data, and which has degree of freedom, right? Sorry, not degree of freedom. The degree of polynomial. My bad. So C value. So C value is the one which is which will tell you, okay, how good your data is, right? Then gamma is the one where gamma, like, it's getting used in the formulas, right? Epsilon, again, it's used in, like, we have hard SVM, then soft SVM. In all those things, we have these hyperparameters which are getting used, right? And these values are nothing but it's using to convert them to understand the pattern, right? So next, what is the point, guys? We have to get our gridsearchcv. And gridsearchcv, what are the things we are using? We have estimator, right? Then we have param grid, right? Then we have CV, like it is using cross validation, and cross validation 5-fold, like it's using the k-fold cross validation and 5-fold cross validation it is applying. And if we go ahead, it will take some time to come up. So let's see. So just if we'll see this data set, right? I mean, you have 300 different train data. So it's going to, take, like, or it's going to divide that 300, and it's going to get, or it's going to fit those different models, or those different data into different folds. So let's see how it's coming up, and it will take some time, guys. By the meantime, let's do one thing. Let's understand on how this, or how our support vector machine, it is predicting the output. So before moving ahead, I wanted to know what are the, okay, let me get it here. What are the data.head? So we have age, gender, education level, job title, and years of experience. So what is my base here, or what is my target variable here, guys? Salary, right? Now for that we have age, gender, years of experience, then we have education level, job title. we will take only one variable and we will see how we can achieve our things. Okay, so how it is predicting, what is the formula for SVM, guys? SVM, we had f of x equal to wx plus b. What is my w here? My w is my slope. Slope means the increment of salary. Increment of salary here. Then my x is nothing but my input, right? You can suppose here I am taking years of experience. So my x is going to be that years of experience, and b is going to be my intercept. That means this value is the base salary when your experience is 0. Then after that, what we are going to do? We have let us assume that we have w, that means the increment, yearly increment, or 2-yearly increment, what is happening, suppose 4,000. Okay, and my x here, or my years of experience, I'm taking 5. Then my b, or the base salary, is 40,000. So what exactly it is going to do? F of x equal to wx plus b. That means it's going to take 4,000 into 5 plus 40,000. That means it's going to be 20,000 plus 40,000. It's 60,000. That means for 5 years, it's going to predict, for 5 years, it's going to predict 60,000. And this is a rough value, I told you guys. It's going to be, if like it is going to understand the error part, it's going to do so. Some manipulation will happen and it is going to give you the output. So this is the basic funda. And if we have almost 5 or 6 features, right? So for that, what should be the formula? F of x equal to w1 x1 plus w2 x2 plus w3 x3 plus b. So here, what is my w1, guys? My w1 is some formula or some value into age plus w2 into years of experience plus w3 into what is the next part? Education level, plus w4 into what we have, education level. Then we have designation, right? Designation plus b. This should be your final formula for your support vector machine, and it's going to take each, like what could be the w1 for this particular value, then what could be the w2 for this one, then w3 for this one, and we have one more value here, right, guys? We have w5 into years of, I have already written that. Yeah, I think these are the factors. So this is how it's going to calculate, guys. This is how it's going to calculate. And let's go back and let's see whether we have got our output there or not. Let's see that. We still have not. Okay, I'll tell you what exactly is going to happen. So yeah, can see that it is creating different 5 folds for 320 candidates, totaling 1600 fits. That means it's calculating or it's multiplying those 300 data sets, 320 data sets into 5. So we are getting 1600 different ways or different training data for it. Then the best hyperparameter it is calculating. Again, it takes some time. Then we are getting the best estimator. Like whatever the hyperparameter it is getting, we are calculating the best estimator for it. Then after that, we are going ahead and predicting on that best estimator. And what is the data we are trying to put there is we are trying to put test data, right, for predicting, for training train data, for testing test data. Sorry, my bad, for predicting test data. Then we have this my y prediction. Then after that, we are going to get our mean square error and R2 score, guys. So this is how our output it is going to be, and how we are going to read it, how we are going to understand what could be our final the final output or the predicted output. Suppose I already told you why we are calculating errors. The errors are the one which is going to be differentiated, or that's the part which is going to be less from the actual value. Suppose I am getting 40,000. I have 40,000 as a test data. If I am getting the mean square error is 500 or 600 or 5,000, then it's going to reduce that amount from that 40,000, and that's going to be your output or the final output or the predicted output, because that error part we cannot avoid. That error part, that's why we have to reduce the error part based on the training. So the more the training is better, the error will be less, and we are going to achieve the actual value easily. So that is all, guys. I think it will take some time, but yeah, I mean, we understood the concept nicely on this. So let's meet during our next video. So till that time, thank you. Bye.